Hey, and welcome to Mathwork. This is Moses Ngambi. So today we'll look at the 2019 past paper, paper 1 for that matter. So this paper was for GCE. Yes, it was GCE past paper. So this is question 23. So the question reads, the diagram below shows a speed time graph of an object. It starts from rest and accelerates uniformly for 2 seconds until it reaches a speed of 10 meters per second. It moves at this constant speed for 6 seconds, then accelerates until it reaches a speed of v meters per second after 5 seconds. So finally, it retards for the next 8 seconds until it comes to halt. So we are going to solve this question, and in a bit I'll show you how the diagram looks. Then from there we'll solve the questions that follows. Okay, yeah, so that's our diagram there. So we'll solve the questions that follows. So let's look at the questions. So the first question is, so our first question reads, we find the acceleration during the first 2 seconds. So we find the acceleration for the first 2 seconds. So our first 2 seconds, we can see it is starting from 0 there to 2. So this in the y-axis, we can see that this is speed in meters per second. Then in our x-axis here, we can see that it is time in seconds. So we are supposed to find the acceleration during the first 2 seconds. Okay, so our acceleration formula is acceleration is equal to, so this is our acceleration formula. Our acceleration is equal to final velocity minus initial velocity divided by time. Yes, then the average speed, which is given by the total distance divided by the total time, where this a is the acceleration, this v is the final velocity, u is basically the initial velocity, then t is time. So using this formula, we can find the first question, acceleration during the first 2 seconds. So from our diagram here, we can identify our acceleration, our velocity, which is the final velocity, then the initial velocity, for us to calculate the acceleration. So from our diagram, we are able to see that our initial velocity is 0, then our final velocity is 10 meters per second. Then we have the difference in time to be 2. Okay, that is the difference in time. So we can use this to calculate the acceleration. So we have that. So we are looking for the acceleration, which we don't have there. Then we have the final velocity to be 10 meters per second. Then we have the initial velocity to be 0 meters per second. Then the time is 2 meters per second. So we can then apply this formula, which is acceleration is equal to final velocity minus initial velocity divided by time, to calculate our acceleration. So okay, there we go. So our acceleration will be 5 meters per second squared. So that this second and this second will make s squared. Okay, so you have 5 meters per second squared. Don't forget to add the units when we are solving this. So that's our acceleration. So let's see our second question. Okay, so our third question is, our second question is, we find the value of v if the retardation is in the last 8 seconds is 3 meters per second squared. Okay, so here they are basically talking about the last this. Okay, the retardation is this, which is basically known also as the deceleration. So we are supposed to find the value of this v in the last this. Okay, so they found that the retardation was 3 meters per second squared. So we are supposed to find the value of v. So let's solve it. Okay, now from our diagram we are able to identify that our acceleration, which is our retardation in this case, is basically okay. So we can see that in the last this, so we say 21 minus 13, we find the time. Okay, so 21 minus 13 we get 8 seconds. Okay, so we can see that if we do 21 minus 13 we get 8 seconds. Then we can see our final velocity in this case will be reducing, so which means our final velocity will be 0. Okay, to be 0 meters per second. Then our initial, since we are starting from here, which means our initial will be this v. Okay, then we are told that in this last seconds we had a retardation of 3 meters per second, so we can use those to calculate the value of v. So we can use this formula again to calculate the value of v. So we can go ahead and do that. So I have come up with this, my data collection. So it's very important and it's easy for you to solve if you have this data collection here. So as I said the acceleration is 3 meters per second squared. Then the velocity, since it will be the final velocity, since it will be retarding, which means it will be 0 meters per second. Then the initial velocity will be v. Okay, then the time, it will be 21 minus 13, which is 8 seconds. So we can use the formula to calculate the value of v. Okay, so I did some basic mathematics algebra there to come up with that formula. Okay, to come up with this formula here. So our v, our u is equal to v minus 80. Okay, so in this case you can see that our v here is 0, then our a is 3 meters per second, then per second square, sorry, then we have time, which is 8 seconds. So we can find u.